Okay, I think most of the people have arrived. Welcome to this fantastic breakfast. What did I say? Breakfast. Breakout session room. It's hard to say. So actually, my name is Göran Berntling. We're going to talk about one of my favorite topics, actually. So it's regarding security, and it's application security. So I'm very pleased to welcome a specialist in that area, Mr. John Wienand from OpenText to the stage. Welcome. Give him a warm applause.
Hey.
Welcome, John.
Oh, thank you very much.
Here you are.
All right. Thank you very much, guys, to taking the time. To start off, I'm Jan. I'm a security pre-sales consultant. That means I'm living in the real world with customers, dealing every day with technical issues. And yeah, I have a lot of contact with customers. I'm based in Germany, and it's actually the second time in this week that I'm in Sweden, because the last 4 weeks I was on vacation in the Nordics for 4 weeks, and I drove through Sweden in 3 days, which was exciting, but a lot of driving hours. But today I'm now here in Stockholm for the first time, and I'm really happy to talk a little bit more about application security, because this is what I do from day to day, but also within OpenText, we do a lot of things in parts of application security. And today I want to talk about the biggest challenge in application security and how we can solve it with AI. But before we even start about that topic, for those of you who are not familiar with application security, let me give you a quick overview about that. So application security is basically a topic where we try to make applications that you have on your phone or also websites like shopping sites more secure. So we try to find potential vulnerability as early as possible and try to fix them. That's a really high-level overview about application security. And why we do that is because imagine you are a customer of a bank, and the bank gets hacked or have a data breach. How do you feel about that? It's like not really good, because you might lose the trust to the bank and also lose money in the bad scenario. And we try to prevent this. And from the company point of view, we try to don't lose this trust. We also try to make the applications more secure. And also, a lot of times we also talk about legal and compliance standards, because it is nowadays really, really popular. And there are different ways of doing application security. The most common one is the one we are talking about today, which is the static code analysis. This is how it's called. And basically what we do there is to look through the code line by line and try to figure out what could be a potential vulnerability before someone else get it and try to use it for bad things. And there are also other things you can do, like dynamic analysis, which is basically you try to hack an application from the outside or an API. But yeah, I don't want to talk a lot about the different techniques. We are really want to focusing about the static part today. And I already talked about why you need application security in your organization. For example, the compliance standards, the legal standards, but also the risk, because this is what security is all about. It's about risk, to manage risk and to understand risk. And in this presentation, as I said, we will cover AI in the coding and application security market in general at the beginning, just a really high-level overview for you. But then we get into the really interesting stuff. Hopefully, the first one is the biggest challenge in application security. And I talk about real-world challenges that I'm facing every day with customers, and then how we can actually solve it using AI really smart. So let's dive into AI in general. I think I had a look at the agenda for today, which is packed with a lot of AI stuff. So I'm sure you're probably familiar with all of these. But I want to highlight here are these drivers on the right side, because when we talk about AI, it should give us any kind of benefit. And of course, we see that benefit in improving the customer relations, but also address shortages if you need to cut off some people and also try to improve the overall productivity of your business. So that is about AI in the market. This is really high level, but now let's dive a little bit deeper how AI can solve the biggest challenge in application security. But the question is, what is the biggest challenge in application security? When I started, it was, I think, 6 years ago, in application security, I had no clue about it. I was really in the cold water for the first time, and I also questioned myself, okay, what is the biggest challenge customers should or can have? The first thing came in my mind is like, maybe it's creation of a compliance or legal report. Maybe it is a dashboarding, something like this, but nope, that is not the case. The second thing is the scanning time. Then I thought, okay, maybe the biggest challenge is the scanning time. So how long does a scan take? In certain areas, this is actually true. This is a big challenge, but not the biggest one. But it's actually not the biggest challenge. So the biggest challenge is actually something that is called an audit process. And for those of you who are not familiar with this, this is really easy to understand, because what we do in an audit is we sort our findings from the scan out into different groups. So as you can see here at the top, we have the real risks, so the real vulnerabilities that are exploitable and need to be fixed really, really soon. And then we have false positives, so findings that aren't actually findings, so aren't real vulnerabilities that occur, and we will also talk about why this is the case. And the third option is accepted risk, because we are working so much, we try to do our best, but we do not have the time to do it all. So then we go into the decision, okay, what of these findings are really important and what are not so important, and where is like, for example, the likelihood so low and the cost so high that we decide, okay, we accept the risk, we will not fix it in the future, but that's fine. And the audit process is all about categorizing the findings into these groups. And this is actually the biggest challenge. But let me explain. Before we get into the audit process, I can give you a very, very simplified overview how this analysis works in the background. Because when we have a look at the static code analysis, what we do is actually we act or we do a code inspection. You can think about like a cooking recipe. So we try to go through this recipe and try to find potential things that are maybe not good in this recipe. And the good thing is we have a look at each line of this recipe, but we're not actually cooking it, because writing code and running it are two different worlds. And in the static code analysis, we only having a look at the code. And this is why we do the code inspection. The second thing is we try to act like a detective. That means we know from the past certain patterns, certain things that are suspicious, and we try to find these. Like when we go somewhere as a detective looking for fingerprints, for example. So, and basically what we do here, we try to find vulnerabilities, but we have some challenges because, as I said, we have something that is a false positive. You can understand it maybe a little bit better like a fire alarm. It's a fire alarm without a fire. That's a false positive. And the work here, or why these naturally occur, there are different reasons. First of all, it's all about context. Because when you hear the sentence, the server is down, maybe you think, okay, it's really down, it's crashed, it's not online anymore. But it can also mean, okay, the server is downstairs. And the same challenge, we have the same challenge in coding and application security, because we not always understand the context of the code from the outside. And this is the first reason why these false positives occur. The second thing is we try to spread the wide net. So, for example, when you go fishing, you get the biggest net, throw it into the sea, and hope that you get as many fishes as possible. But sometimes there are things in it that you don't want actually to catch, like dolphins or whatever, and you throw them back again into the sea. And we do the same thing in application security or in the static code analysis. We try to catch as many as possible, but not all of them are real vulnerabilities. And this is the second reason why false positives occur, because it's always better to have all findings instead of leaving something out. And this is why false positives occur. And the third thing is, the people of you who actually coded once or seen code know that there are 1,000 ways of cooking an egg in coding. So you have really thousands of ways to do the simplest things, but the goal in all cases is always the same. So this is the third challenge, or the third reason why false positives naturally occur. And as I said, in this audit process, we start to sorting out the catch. So the real vulnerabilities that we need to fix and the rest. And this is all what the audit is about. And the good thing is, when we do that, we actually ensuring the accuracy from the scan, because every time we do that, we learn over time from scan to scan, and we make the accuracy better and better. And the third good thing about an audit is also that we automatically setting priorities. So that means what is important, what do we need to fix first, what is something that we can do in the next week or in the next month. And we have, unfortunately, a lot of challenges in this audit process, because first of all of this takes a ton of time. Just to give you an example from some customers who did scans in their environments. For example, we have a 10-minute scan that give you 300 findings. And these are critical, these are medium, these are low, just best practices. And if you just need 1 minute per finding, you can calculate easily how this sums up over, for example, over a year. So you spend hours and hours auditing, and that's a big challenge. So it's really, really time consuming. And the second thing is you also need expertise. So you need experts who, first of all, need to know how to code, of course, but also understand your company, how the company structures, how you do things, what kind of compliance standards you have. So you really need experts to do these things. It's not easy to get like a student on the table to do these things. You really need a big knowledge of not only your company, but also coding in general. And the third thing is all this concludes into delays in the software development, because software development is all about time. The reason why you get updates on your phone every day or maybe every week is because the development process is so optimized that you can get these updates so frequently. And if you put security in the middle of it, the first reaction might be, oh, then we lose a lot of time. Of course, you put security into your applications, but sometimes people say, okay, it's not worth it. We want to hold the speed. But the challenge here is really that it delays the software development, and we don't want that, obviously. And these are the challenges in the audit process. And at the end, I want to talk about how AI can actually help you solving these challenges. And as I said, I'm from OpenText, so we have, as you might expect, a big portfolio in this application security market. but one particular thing that I want to talk about is something that we call Fortify Aviator. It's the only product name you see in the whole presentation, but what it actually does, everything with Aviator at OpenText does mean that we do something with AI in it. And what we do in application security with this Aviator is we do a large language model-based auditing. So what does that mean? As you might know, large language models are pre-trained models that not only understand human language, but also these are really, really good coding languages or models. So they understand coding as well as human languages really, really good, which is a superpower, I would say. And this allows us to use large language model to help vet during the audit process. So what we do basically in the background is to pack everything that we need, everything that we know about certain vulnerabilities, like the source code from it, all the data from us that we have searched in our, that we did in our research phase, and send that to a large language model. And then we get something back, which is really powerful, because what we get back is not only information about is this a real finding or not, but also an explanation about that. Because we're talking about generative AI, we can get text or explanations why the large language model thinks that this is a potential risk or not. And the good thing is here also the recommendations, because it will not only boost the productivity because the developer don't need to take so much time anymore, it will also boost the enablement based on the recommendations. Because we also have other solutions who does like the categorization of the findings into false positives and true vulnerabilities, but with generative AI, we are now able to also explain that, and that's the most powerful piece of the whole solution. Because then you not only get a list of potential finding, you get an explanation why this is a real vulnerability and how this can be used in a bad way, and this is really, really powerful. And to give you 2 examples at the end of the presentations, I have actually 2 examples, one false positive and one real vulnerability. The first one that you can see, hopefully could see, is something that is called a hard-coded password. To explain you what is going on here, a hard-coded password is nothing else than a potential password that is written in your code. And why this is bad? Because if someone gets access to the code, maybe they get access to the database that is behind the code. And a hard-coded password is exactly something that we call a category of vulnerability. And in this case, the scanner detected a hard-coded password in the code. But as you can see, there's a variable called password, and the value of this variable is called please provide a password. And of course, this could be a password, but probably not. But because the scanner does not know that or flag that as a potential risk, we know within seconds that this is not something we need to care about, probably. And this is what we also get from the Aviator as a feedback, completely automated, so we don't need to do anything else. So what it does, it first of all sets the status from like pending review to not an issue, and also explains why he thinks that this is not a real vulnerability. And that is really, really powerful. And imagine this is a really simple example, but imagine someone needs to do that in this security team. It can take a couple of minutes. If you get complexer cases, it can really take up a lot of time. But where this Aviator is really powerful in is the exploitables, because in this example, we have something that is called a SQL injection. For those of you who are not familiar with this, it's really simple because, for example, if you imagine you have an online shop, you want to shop, I don't know, some trousers, and most of the time you have a search bar and you can put text in it. And without verify what you put into the text, you can do a lot of things. You can even delete the whole database with all your products in it. And we obviously want to avoid that. And because we do that, we want to avoid that, we try to search for SQL injections. So SQL injections are the attack mechanism behind it to change data or delete data. And in this example, it's a little bit more complicated if you're not familiar with coding, but what it basically does is exactly that. So you see, for example, there's a username and a password, and there's no verification of the data that you put into it. And that's a real vulnerability and a real potential risk that you need to fix. And the good thing here is the Aviator also sees that as a vulnerability and set the status from pending review to remediation required. So someone from the experts team should take a look at this and try to fix it. But the good thing here is not only that you get the same explanation as before in your language, so in your program, in your coding language, you also get code remediation directly in the comment as well. So something that you could theoretically copy and paste from this feedback into your code base. And that's really, really powerful because this can take up a lot of minutes, maybe hours, to figure out how to do that, and you don't need to do it on your own. Of course, that's not the golden solution for everything, but it's a good way to start and to enable developers to learn more about the vulnerability and how to fix it. And yeah, this is everything I want to show. I thought it would be better to have a little bit more time at the end. If you need any kind of information, if you have questions, if you have some tips in Sweden for me to travel to, I don't care, please come to our booth. It's really simple to find. You just need to open the door and you're there. That's it. So thank you very much for your time and have a nice day.